Bonnie,
right.
please.
The meeting is now being recorded. That means I am being recorded. I want to thank you all for your participation. It's very nice to see so many faces. It's also wonderful to see so many students. I am very, very thankful that many students are here. And I would love to see every single student's face. I'm wondering if you could all leave your audio off and turn on your video. I know it may take a few minutes, but when you have your video turned on, then I will take some screenshots. I appreciate your being here, and I'm ready to have the students who are going to be speaking start speaking. And I'm wondering, is Amritanshu going to introduce them, or is Suresh going to introduce them? Amritanshu. All right. So I'm going to turn this back over to Amritanshu and have him introduce the three students that will be speaking one at a time. And I'm very happy for this program. Thank you. Amritanshu has done a lot of work with it. And in fact, Amritanshu has done pretty much all of the work with it. So I'm applauding him and I'm nominating him. I'm making him a full ambassador for Educational Continuum. Thank you, Amritanshu.
Thanks a lot, ma'am, for your kind words. And with these words, we formally begin the proceedings of the final day of this iSTEAM Lunar Nights, registered under Office for Astronomy Outreach. And today we are on the final day of this very, you can say, interesting program, once of its own type, because we had never done such an exercise before. And I take this opportunity to welcome the Director of Educational Continuum, Ms. Bonnie Vitruber, who is joining us directly from Chicago, USA. Welcome, ma'am. I also take this opportunity to welcome our mentors who have been the backbone or the pillars of this entire pursuit of the last 4 days. I am only the mouthpiece, but there are a lot of people who are involved here. Welcome Shri Shovan Acharya sir from SA Citizen Science Group. I also welcome Mr. Suresh Mediru from Vishwamitra Amateur Astronomers. I also welcome our honorable mentors like Prabhat sir, Shri Ashwini Shenoy sir, also Ananda Babu sir, PVLN Sriram sir, Chitra ma'am, and all the people who are behind the curtains. So welcome all. So today, as we are moving towards the culmination of the program, so I have been given the opportunity by Bonnie ma'am to present the report of what we had done in the course of all these 4 days. So let me just begin with a few statistics. This entire program of iSTEAM Lunar Nights, when it started, registered under the IAU 100 hours of astronomy under the Office of Astronomy Outreach of IAU. It began with registration from these nodal centers of Chicago, Farrukhabad in Uttar Pradesh, Bhopal in Madhya Pradesh, India, Sri Kalahasti in Tirupati of Andhra Pradesh, Hisar in Haryana, India, Pune of Maharashtra in India, Rio de Janeiro from Brazil, Vijayawada from Andhra Pradesh, and Delhi in India. So it was, you can say, a humble beginning, but you know, we had never imagined the amount of the registrations that we encountered firsthand in the Google form. Ranging from a team of a single member to a team of 150 students, we had the registrations from India, from Bangladesh, from Brazil, from Israel, from Romania, from Tanzania, and USA. So you can say it was a mini sort of a conference on this virtual platform that we have been doing. Under the course of all these 4 days, we had seen a few sessions on mobile astrophotography, that is smartphone astrophotography. We had also seen a reflection on how this astrophotography really works when we try to communicate the science, as taken by Mrs. Chitra Singh from Dr. Iravati Karve Science Club. And at the same time, we had also seen a little bit of tinkering with the micro observatory, the robotic network of telescopes. especially by the students from the region where the moon was not there, the sun was not shining because it's raining in different parts of India. They really experimented with it. We also had a session on cultural astronomy that was led by Bonnie Truber ma'am, the director, Educational Continuum and iSTEAM Cosmic Academy. So it was really, you can say, a complete compendium of different activities that were loosely bounded under the guidelines that we had submitted to International Astronomical Union's Office for Astronomy Outreach. And I'm proud to say that I am very much proudly announcing that at the moment we can say the program has seen a grand success. Now, there are a few names which really need to be taken when we are dealing with the success of all these things, especially when the extension of all these activities began. Definitely, it was one of the most prime places to mention is Guwahati, of very far northeast in India, where the region, you can say, the land of the rising sun as far as India is concerned. From Arunachal Pradesh and Guwahati, it is led by three teachers, very dynamic teachers, Shri Rajiv Ranjan Dhar, Shri Mrs. Rabia Begum, and Shri Raja Sarkar sir. So really congratulations and hats off to your efforts that this program has seen the reach further into the northeastern part of India, bordering the far Southeast Asian nations. So really thanks to you that you took this iSTEAM Lunar Nights to at such a distance, at such higher level. I also would like to congratulate the Atal Tinkering Lab of Bilaspur in Chhattisgarh, coming from a very, you can say, tribal region of Uttar Pradesh, of Chhattisgarh in India. These students, they, you can say, really worked against the tides of the weather and the season. It really was, you can say, raining cats and dogs, as we say in English. It was profusely raining for last 4 days, thunderstorm, and they were not able to do a single observation on the course of the 4 days. But you know what they did? They resorted to the cultural activities under the leadership of their mentor, Dr. Dhananjay Pandey. Competitions were regularly organized. The essay writing competitions were organized. The drawing and painting competitions were organized. And yesterday, late in the night, when they got an opportunity to see a little bit of moon and the other things, they captured the moon, not with robotic telescope, not with the smartphone, but with the telescope. So that was the only missing feature in this entire program. And that domain has also been covered courtesy to the students of Atal Tinkering Lab, Bilaspur. Congratulations to Dr. Dhananjay Pandey and your team. I also take this opportunity to congratulate Shri Shobhan Acharya ji, who with his India-wide and even beyond the India network of SA Citizen Science Group took this entire program to Bangladesh, to Haiti in USA, and also to the different states of Uttar Pradesh, beginning from Delhi to West Bengal to Maharashtra. And as we can see, it is reflected on the Padlet also, that really the amount of the engagement and the participation, the depth of the participation can really be seen from the number of the posts as that are being done by the participants of SA Citizen Science Group. And last but most important, 4 important names. Dr. Shivalika Sarkar's team City Stars from Bhopal has, as it says, the center of India, has served as the central point over which all the 3 activities revolved that we planned, really, from the smartphone photography to, you can say, the cultural astronomy to the micro observatory. And all the students like Anushka Shauri and all the students led by under the guidance of Dr. Shivalika Sarkar, they have performed really well, and they have engaged not only at the educator level but at the level of being a student. So congratulations to your team and the 3 most important teams who really have been the backbone of this entire program. From the NTR district, the team led by Shri Suresh Meduru, he is one of the mentors. And he is the testimonial of the fact that what hard work can really do. Beginning as an individual participant, progressing as a team participant, and progressing as a team mentor, and then becoming the mentor of the program and also one of the keynote speakers in this entire program. The team of the 30 students and majority of the whom have been present for all the 4 days. It would be, you can say, I am really short of the words expressing my wholehearted thanks to Shri Suresh Meduru. And also, I would like to congratulate the team led by Mr. PVL in Sriram from Konasima district of Andhra Pradesh. Welcome, really we welcome the team members and the students of PVL and Sriram sir, and not to forget Mr. BLV and Ananda Babu sir from Rajahmundry district of Andhra Pradesh. You really have worked wonders while assembling this entire, you can say, program while communicating the things that we wanted to share with the students. So thanks all. And I might have forgotten to take a few names, but I hope that you will forgive me. But these are the cornerstones or the pillars. And I also would like to extend my wholehearted thanks to two of the most important people who are a part of iSTEAM, but because of health issues and their personal engagements, you might not have seen them, but they've really been the powerhouse of the entire source. This Mr. S.N. Sugma Iyer, who is, you can say, not healthy, not fit health-wise. You might have seen him on the first day, and he is, you can say, down with a little bit of fever, but he has been the real powerhouse. And also, not to forget Dr. Iyer, he is a retired scientist, and his inputs, they really have worked wonders while we are planning the entire program. So this was a short report that I just wanted to say, and I take this opportunity also to welcome our keynote speaker, Dr. Margarita Safanova, who is joining us from IAA Bangalore, and her session shall begin after we announce the upcoming programs and have a little bit of feedback by the students. So now, without further ado, let me invite the student, they 3 or 4 students have agreed for their feedback today, beginning with, if Harshita, you are here, I would request you to kindly unmute yourself. If you can put your video on, and we would request your kind feedback, how you felt on this journey, and you have got about a minute or two to express your feelings. Suresh sir, kindly guide Harshita to be on the front board. Harshita, over to you.
Good evening to everyone. This is Mullangi Harshita representing ZPH School Nunna. It is my privilege to participate 4-day orientation program on Lunar Nights. And I learned the uses of Padlet, and I learned how to take photographs with mobile phones. It is extraordinary. I also learned how to send a request through Micro Observatory NASA. I also learned how to process the image which got from Micro Observatory. I have so many doubts while processing image, and I need some other program to make how to analyze the images. I am eagerly waiting for the future programs regard to astronomy. I am very thankful to Boni ma'am and Amritanshu sir and for my school for creating this opportunity. Thank you.
Thank you, Harshita. So kind of you for such kind words of appreciation. Let's have a big round of applause on this virtual dais for the participant, Harshita. Now, moving forward, I would like to invite the second student who has agreed to share the feedback is Gagana Sai Shri. Gagana, if you are here, I would request you to put your camera on and kindly share your feedback to us. Please unmute yourself. Gagana, over to you.
Good evening to one and all. This is Gagna Saistri from ZPHS Nunna. This is my privilege to attend the conference of Lunar Nights. I am very thankful to Boni Madam for giving me this opportunity. Through the conference, I learned how to use Padlet, how to post in Padlet, how to comment on others' opinions. I also learned usage of mobile for taking photographs of moon and stars. I want to learn more about the usage of mobiles for taking photographs. If there is possibility to conduct another class on mobile photography, I received moon images from micro observatory also, but I'm unable to process the images on my computer. I need a lot of practice. If possible, conduct another class on image analysis. I'm very thankful for my school for providing me this opportunity. To learn more about astronomy, I want to participate some more programs. Please conduct these programs keeping in the view with the local criteria and timings, especially in holidays, to avoid a disturbance for my studies. Thank you, one and all.
So thanks a lot, Gagana. And we definitely shall take into account the suggestions of yours. And definitely we are planning a host of the other programs. Keep in touch with us. And we are
Thank you,
really
sir.
thankful to you for sharing such a, you can say, a impartial feedback to us with all the critical comments. We definitely shall incorporate your suggestions to the maximum extent possible. Thanks a lot, Gagana, again. So now I will invite Mohnish Dhruv from ATL Bilaspur, if you are here, and Dr. Dhananjay Pandey to kindly assist Mohnish group, because Mohnish will be talking in Hindi language while his mentor Dr. Dhananjay Pandey shall be translating it in English for us. Mohnish and Dhananjay sir, the stage belongs to you. I request Mohnish to kindly Mohnish आप अपना कैमरा ऑन कर लीजिए ताकि हम सभी लोग आपको देख सकें अगर आपके संभव हो सके तो. धनंजय सर प्लीज.
यस नमस्ते सर. नमस्ते सर. सर मेरा कैमरा क्या खराब है तो आप मेरा मतलब पिक्चर नहीं देख पाओगे इसलिए
बिल्कुल
सॉरी.
बिल्कुल आप अपना
आप-
फीडबैक प्लीज शेयर करिए मोनिश. धनंजय सर आप प्लीज ट्रांसलेट करिएगा, आप भी अनम्यूट कर सकते हैं.
यस सर, मेरा नाम मोनिश ध्रुव है, मैं अटल चिकिला बिलासपुर से हूँ. सर मैं तो बस इतना कहना चाहता हूँ कि सर पहले हम लोग है ना मून के बारे में इतना कुछ जानते नहीं थे, और अभी हम लोग के ऐसे मीटिंग्स जैसे डोना नाइट का जो मीटिंग चल रहा है, इन सभी मीटिंग से हम लोग को बहुत सारा नॉलेज मिलता है. अभी तक तो हम लोग सिर्फ उसे चंदा मामा है, हम उसको ऐसे बोलते थे सिर्फ चंदा मामा, पर हमारे मामा के क्या क्या गुण है, वो सिर्फ चमकते हैं, पर चमकने के साथ साथ और क्या क्या करते हैं ये सब चीज हमें पता चलता है. और सर ये बात मुझे बहुत अच्छा लगा कि हम लोग जो पेंटिंग्स है, पेंटिंग के जरिए अपना अपने चांद को अपने पेंटिंग के जरिए दर्शा रहे हैं. और सर मैं चाहता हूँ कि सर इस तरह के प्रोग्राम ना होने चाहिए, क्योंकि इस तरह के प्रोग्राम से हमें अपने अर्थ के बारे में, मून के बारे में, सब चीज के बारे में नॉलेज पता चलती है कि हमारे मून में क्या हो रही है, क्या हो रहा है. वो सिर्फ चमकता है, हम उसे मामा बोलते हैं, तो मामा के साथ साथ वो और क्या क्या काम करते हैं हमारे मामा, ये सब चीज हमें पता होनी चाहिए. इस तरह कैसे इसलिए प्रोग्राम होने चाहिए. ठीक है, थैंक यू सर.
धन्यवाद मोनिश. धनंजय सर प्लीज ट्रांसलेट, प्लीज शो टू अस व्हाट मोनिश has just said. It will be beautiful.
Actually, Monish was talking in a very familiar language with we used to do. In Bilaspur, we usually talk the moon as a maternal uncle. So he says that till now we used to know that these are maternal uncle, but by this program we knew that what is the moon, what is the intensity of the moon, what is the program of the moon, how the moon shines, and all the things. When we went to learn something about the moon, it causes a great effect to us. So this type of program should continue and should be there for the whole.
Good evening, everyone.
So that we could learn more about the moon, and this was a fantastic program.
Hello, good evening, everyone.
Which it united all the things, including the astronomy, the photography, the poems, the capturing. These all things has came into one segment, and it was appreciable. So he urged that to continue this type of program so that he could take and not Monish, all the tribal students of here Bilaspur could take this program. Thank you.
Thanks a lot, Dhananjay sir, for this beautiful explanation of the thoughts and the emotions of Monish. And we definitely assure you that we shall continue. हम लोग ये प्रोग्राम जारी रखेंगे. In the forms might change, the ways of presentation might change, the context might change, but such programs by iSTEAM, they shall continue in the days to come. So the final student of the day who has agreed for the feedback is Anusha. So Anusha from Team City Stars, I would request you to kindly unmute yourself. If you can show us your video, we will be keen and eager to have your feedback in a couple of minutes. And you are the final student of the day. Anusha, over to you.
Yes, sir. Myself is Anushka Chaure from Team City Stars. Thank you all the teachers for providing this unique opportunity to me. I am delighted to be a part of this group and I learned many new things regarding moon and different constellations. And in every meeting, there was something new to learn, and I look forward to every meeting. And of course, taking images from micro observatory and exploring the sky charts. And it also improved my photography skills as I learned about many new aspects of photography like ISO and shutter speed, etc. So this was very enjoyable, and I'm looking forward to the next astronomical any program which is happening. Thank you.
Thank you, Anusha. And so, even though we may not be able to take the feedback of all the students in this, you can say, short span of time, but we definitely shall try to, you can say, have a special segmented video And what we request you is, if you want to submit a feedback to us, you can record a short video of yours and email to us on the emails from which you have done the registration form. We shall send you a space, and we assure you that all your videos on that particular feedback, they will be combined into one, and they shall be uploaded on the platform that we are utilizing on that YouTube platform for popularization of this astronomy feedback. So now, as the time is approaching for the what can be said, the keynote session of the day. So before that, we have got two, you can say, very important announcements to be made. So let me just immediately share the screen in front of you all, and I hope that my screen is visible to you. Is my screen visible to you? So I take this as an opportunity to okay, sure.
Yes,
So
sir.
sure, sir, sure. So
Yes.
I request you all to kindly keep yourself muted so that you can say keep on doing the announcement in time, and so that you really are able to enjoy the keynote address by our keynote speaker of the day. So first of all, we just wanted to give you a hint that in this Lunar Nights project, when we had tried all these three activities, photographing the moon, and then apart from that, taking these images of the celestial objects via the NASA's micro observatory robotic telescope of network, and then we had done a little bit of cultural astronomy. So this is not the end. This should be the first step. This is just a beginning for you all. And so here are a few of the programs in which you all really can try your hands. The first of the important programs that you can do is a moon differentiable background, and these programs, they really have been suggested by our mentor. I request you all to keep yourself mute. So this program, it has really been suggested by one of our mentors, Mr. Shovan Acharya. You can just go through it. It is a very, you can say, interesting program that is being rolled out by NASA. I request you please not to annotate the screen because it interferes really when all are talking. So I am just removing that annotation. Please take care. So now this is a moon difference program. You know, Apollo landed, and since Apollo, a lot of changes might have happened. So this is a comparative program between the images that really. I request you not to annotate the screen, my dear friends. So else we will be very, you can say, sorry to remove you from the meeting. So the matter of fact is, this moon difference is in the background is one of those premier programs of studying the backdrop of the moon that has been rolled out by the space agency of NASA. You can go through it, and this is in fact an image preparation, and you can do a lot of citizen science work at a very elementary level by going into this. We shall provide you the link for this particular program. You can go deep into it. Then apart from that, you can have a little bit of insight into this Sungrazer project that is again taken by as a citizen science project by ESA, NASA's the Solar Heliospheric Observatory SOHO, and you can go into it. You can join this program, and you really can go for you can become a comet discoverer in the days to come, and which might be in the tune with the keynote talk of the day. And the third important program which really can look at it is NASA's Space Place Art Challenge. So this is, you can say, some sort of a cultural type of a thing in which you really can express your opinion, you can express your views in the form of those cultural ways, how to do the things. So these are the three important activities. I shall share a little bit about this. And fourth important activity that you can do into is, and this we shall be taking it as a part of the Moon Over Us also. You can join us in this activity, look at the moon, and it is a journaling type of a project. We shall take it out in detail when we are going to discuss Moon Over Us in the days to come under the patronage of Bonnie ma'am. So these are the 4 citizen science projects which really are available at the international level. Now, a little bit about the iSTEAM programs in the future. These are the 3 programs which we are rolling out for the students at different levels. And beginning at the advanced level, we shall move to the intermediate level, and we shall then go to the basic level. So the first program that I announce on behalf of iSTEAM Educational Continuum is 100 Global High School Teams with Miss Bonnie Gruber and Edward Gomez as the principal investigators of this program. I proudly announce that iSTEAM Educational Continuum has become a global sky partner of Las Cumbres Observatory. And under this program, we allow the students of senior secondary, graduate, and the postgraduate level to engage with us with the help of 0.4 meter robotic telescopes, facility of Las Cumbres Observatory at the global level, and explore the objects like galaxies, nebula, globular, and the open star clusters to, you can say, the detail in which you can explore as much as you can in the academic terms. And as far as the credentials of these programs are considered, you can see this program has been active since August 2022, and we are happy to say that we are running into the second continuous cycle of this project. And it's an online sort of a training mentoring program where we really take you deep into the universe with the expert advice from the amateur as well as professional astronomers on the professional softwares, where we explain the very subtle features of the universe for your outreach as well as your personal and the team's academic benefit as well. Last year, about 10 students did their BSc project from this particular initiation of 100 global high school teams, and one student was able to complete his master's thesis from University of Lucknow in India by utilizing this particular facility of 100 global high schools, doing a little bit of photometry work on exoplanets. So you could be the next. So I wholeheartedly invite all the teachers, all the students who are interested as to join us in this global sky partner pursuit as part of the 100 global high school teams. The next short announcement will be made by our Suresh Meduru sir. So I am stopping the sharing of the screen. So over to Suresh sir.
Greetings to all. Sir, this is my privilege to announce that MoonOver under the guidance of Bodhi ma'am. MoonOver, it is a program. It related with moon and other objects. Sir, are you able to hear me?
Yeah, we can hear you. We can hear you. Please continue, sir.
Okay, sir. So this MoonOver program promotes the students to observe the moon at different continents, and at the same time, students are easily able to understand the distance between moon and earth, and what are the differences between a first moon, a new moon, waxing moon, and crescent moon, and different full moon, and they are able to post their experiences and their images, their presentations in the Padlet, and they are able to learn how to comment the others experiences, and they are able to learn the different cultures and different heritages in regard to moon. And at the same time, people are able to adjust their time with their academics, and at the same time they apply their textual knowledge in their regular life. Now I am handing over this stage to Amritanshu ji.
So thanks a lot, sir. And this is an extended version of MoonOver, where the students, they really can apply their hands-on knowledge on the 0.4 meter robotic telescope utilizing the LCO kiosk facility. This program both of these programs that we have announced, they are slated to begin in the month of November. Now, the most important announcement that is to be done by Ms. Bonnie Bithubar before we have the keynote session of the day. So, Bonnie ma'am, over to you so that you can formally announce the MoonOver as a program, the traditional MoonOver. Over to Bonnie ma'am. Suresh sir, please start sharing your screen. Bonnie ma'am, you are muted. You are muted, Bonnie ma'am.
I'm very good at muting. So I am very excited about having every one of you here. We have the MoonOver in iSTEAM for students who are 8 to 12, and they learn a lot about the moon. They learn to take pictures of it, and they also learn to, they also write poetry and tell stories and draw pictures. And I would like to see everyone between the ages of 8 and 12 that's in this course, in that course. Then we have another course, Moon Over Us, for ages 13 to 16. And those students review the first Moon Over Us, and then they get into how to use micro observatory to observe the moon, to take pictures of the moon, to find the places in the moon that have craters, to actually learn how a crater works, to measure craters, to have things that are local to them, see if they fit into craters or a crater fits into them. And I think both the Moon Over Us programs are very exciting. I think the astrophotography program that Amritanshu teaches is also very exciting for kids who are over 16. So if you know who's over 16, get them into Amritanshu's astrophotography course. If you know anyone who's 13 to 16, get them in the Moon Over Us course for that age group. And for younger kids, the Moon Over Us 8 to 12 is wonderful for them to write creative stories, draw creative pictures. I actually have a picture that someone drew of a waning crescent moon that looks just like a banana. So it was inspired by this screen. And you would see, instead of bananas here, these would all be waning or waxing crescent moons. And then videos are also important, drawing pictures, singing songs. And Chitra, Madam Chitra, is very good at the writing poetry and singing songs about the moon part of that program. And I encourage you all to join that program, to join the 13 to 16-year-old program. Those are programs about the moon. I hope that someday I will be able to come to India and meet you all. I don't know right now when that is going to happen. I know yesterday someone posted a questionnaire about having that happen in January. So we should. I would love to congratulate you all in person for the wonderful work you're doing about the moon and about astrophotography. So now I'm going to turn this back over to Amritanshu. Thank you all for being here, and thank you for your wonderful moon and star images.
Thank you.
Amritanshu?
Thank you. Thanks a lot, Bonnie ma'am. So this traditional Moon Over Us, which is a 8-week program, it's slated to begin from 14th of October. I wholeheartedly invite you all to be a part of this pursuit in the days to come with your students, because that is more student-centric program. And we are not just talking in terms of program. See, what we do, we document the things and we present also. I am very much proud to say that this year we had 2 full-length paper presentations at the STEAM conferences done by National Council of Education, Research and Training, NCERT India. One, that paper was presented by Shri S.N. Sukumar and Mrs. Chitra Singh, Project iSTEAM Moon Over Us, Empowering STEM Education Through Hands-on Astronomy. The second paper I had the privilege to present under the guidance of Bonnie ma'am of Las Cumbres Observatory Robotic Telescope Network, Exploring the Frontiers of Space Through Hands-on Astronomy and STEM Education as Global Sky Partners. We also had, you can say, paper presentations and conference presentations at different international conferences as well. So by participating, you can also become a part of the academic circles. And I'm very much proud to announce that one of the papers that we had presented and on Las Cumbres Observatory has been accepted by a peer-reviewed journal for publication in the week gone by. So now with these words, I now proudly announcing the arrival of the keynote speaker of the day, Dr. Professor Margarita Safonova, from IIA Bangalore, Indian Institute of Astrophysics, Bangalore. Her, you can say, we are really short of words if we start talking about the quantum of the scientific and the outreach work that has been taken by Dr. Margarita ma'am. But really, you can see how much she is engaged into deciphering the knowledge that she has gathered over the period of time. You can say just she came yesterday, and at a very simple request, she humbly accepted our request of presenting a keynote address. She shall be taking you diving deep into the world of astronomers and how to perform or how to work as the astronomers do. So she is joining us live from her place institution at IIA Bangalore. So over to Margarita ma'am for your kind keynote address. Welcome ma'am on board iSTEAM.
Thank you. Thank you for inviting me here. I hope everyone can hear me.
Yes, definitely ma'am.
I'm using this external mic. That is why.
Yes, ma'am. We can hear you and we can see you also.
Great. So just to introduce myself, this is the web page of our institute, Indian Institute of Astrophysics. Anyone can go here and
browse. You need to share the screen. Ma'am, you need to share the screen.
Oh, sorry. Yes. Sorry. I jumped ahead of myself. Okay. Can you see my screen now?
Yes, ma'am.
Okay. So can you see the web page?
Yes.
So this is the web page of our institute, and anyone can go here and see what we're doing. There are centers. Our institute has many observatories, space and ground observatories. And if you go to outreach page, there is a special department in our institute called outreach department, which does a lot of many interesting things. And in that outreach, if you click on astronomical events, here you will see my images. So all the images of comets I've taken over several years using our telescopes, with the information on these comets, with some small analysis of these comets, even with some movies, like here, of a comet, for example, this comet. So you can see it's very interesting. It's actually moving along the tail, not away from the tail, but the tail is actually in front. So you can go here, look at all these my images. And now, essentially, what I wanted to say today is that there are not very many astronomers in the world, actually, professional astronomers. Most of us, we know each other by names, if not personally. But as you know yourself, how many telescopes are launched, how many observatories are on the ground, we humans, we want to study the universe. And that is why we send telescopes, we build observatories in radio wavelength, in optical, in infrared, everything. And the data, now astronomy is suffering from a data tsunami, because the data comes in such quantities, terabytes per day, petabytes per day. There are not so many astronomers who analyze it. That is why the citizen science astronomy was actually initiated to begin with, because there's too much data and there is not enough people. So that is why we want to bring astronomy to the people. For example, I have a lot of data. This data, of course, we use. We write papers, we write theses, we give talks, but most of the time, these papers are professional or books. They're highly specialized, and they're not accessible to the general public or even to the students. Public, of course, may hear the final results if it is major discovery, but what went into obtaining that? How do we do this data? How do we get the data, how we analyze the data? That original nitty-gritty data, as I call it, remains usually unknown to the public. And very often, actually most of the time, after being used, the data is stored, archived, what we call. And those archives can sit there for decades. But is it possible to actually reuse this in our teaching of the methods which we use? In other words, can we communicate the data to the public? So this is what I want to talk about. And for example, I love comets, as you noticed. Moon over us is also very important. Moon is over us, and Moon is our nearest free floating, so to say, astronomical object. But comets are not too far away either. Comets are also over us, and they're part of our solar system. So can we teach with what can we teach with the comets and how? So the famous comet hunter David Levy said once, comets are like cats. They have tails and they do exactly what they want. And they actually do. But that is why they're interesting. So why comets? You can ask, why do I care about comets? Well, comets are very pretty. They're very pretty. And their remains give us beautiful phenomena. Meteor showers, nucleolucent clouds, those clouds sometimes that you see glowing in the northern, mostly in the very high latitudes, zodiacal light. Comets are also, sorry, I'm stuck. Comets are also huge. See, this is not a real picture, of course. This is a Earth and example of the comet Isen. This is how it looked. It is a comparison. It's not a real picture, but and you can ask, you can have this question in the class as a after knowing this, that what is the largest object in the solar system? Everyone will say, oh, of course, sun. Actually, it's comet. Comets can grow when they come closer to the sun, larger than the sun. Here, for example, in November 2007, the comet Holmes came and it blew its coma, it means atmosphere, so much that it became in diameter larger than the sun. In 1996, there was a comet which was had tail 3.8 astronomical units. It's approximately distance between from Earth to between us and Jupiter. This record was broken in 2002. The comet had a tail of about 7.5 astronomical units, and distance Sun to Jupiter is only 5. Can you believe that? This is the biggest object in the solar system, the largest. And of course, comets are very profound. Their nuclei contains a variety of organic components, like methanol, hydrogen cyanide, formaldehyde, and so on and so on, and more complicated molecules, and even amino acids. In one of the comets, NASA spacecraft Stardust found glycine, and our life on Earth is impossible without glycine. So it is possible that comets brought organics to our planets when they just formed. And not only that, they brought water also. That comets do have water is shown by all observations till date. And the comets do bring water to planets is illustrated by this beautiful example of Levy-Shoemaker comet, which hit the Jupiter in 94. So by observations in this paper, it was said by Herschel's infrared observatory, space observatory, that 95% of water which is seen now in Jupiter's atmosphere comes from that particular comet. And comets, of course, they're fun. Comets are just fun. So what is a comet? What is essentially a comet? So comet has nucleus, roughly 200 kilometers, what we call atmosphere. It's a coma. And it can grow up to 100,000 kilometers across, or even more than the sun. Then hydrogen cloud, dust tail, and ion tail. Usually ion tail is straight because it is very light. Mostly it's ions, so they respond to the solar wind. And the tail is usually heavy because the dust particles, and it is curved because it follows the orbit. So what major comets we have? Some comets come from Oort cloud and short period from Kuiper belt. Kuiper belt, they are remains of planetesimal, so that they were born just beyond Neptune orbit. The best known example is Halley's comet. Everyone heard about it. Oort cloud can contain actually billions of comets. It's very far away. And we know approximately for definitely more than 3,000 of them. So this is the picture of the Kuiper belt. This our sun, our orbits, and this is the picture of the Oort cloud, which makes out of billions of comets. And this is our solar system. So what else is, why do we care about comets and like, let's say, observing them throughout as they come close and close and their speed increases? Because the speed of the comet is very important to determine where the comet comes from. In 2019, there was interstellar comet. How do we know it is interstellar? Because it was moving too fast. So if you calculate its speed, it was moving too fast to be a member of the solar system. So all the members of the solar system, there's something which is called escape velocity. I hope you already know, our participants know what is it, what does it mean. And so if escape velocity is higher than escape velocity from the sun, then it is not a solar system object. It comes from somewhere outside and it will go away. So here is some comparison on the speeds. So that comet Borisov had much higher velocity, so at least at more than 30 kilometers per second. So that is why it was inferred that it is an interstellar comet. So, but can you actually, using the images that we astronomers observe like this, can you calculate the speed of the comet at any distance from the sun yourself? For example, I observed this comet, ISON, in 2013 from January. This is February, May, then September and October. And as it was coming closer, it was, of course, growing in size, and it was actually moving faster. So here's the video of comet in February. So what data actually represent? Of course, we published this data in this publication, all the images. So what does this mean? What does it mean? So this means that, there are this, for example, 5 frames, what we call frame, first, second, and fifth. So as you can see, these frames are aligned on the stars, and you can see that comet actually misplaced. Yeah, if you compare first with the fifth, you can see that comet moved to the left. So knowing this, how can we use this to calculate its speed in January? Okay, so what we do, we follow the certain steps. First, we find the celestial coordinates of the comet in those images. So you already know what is FITS by using LCO. So FITS at Flexible Image Transfer Service. And it is very good because it is 3-dimensional. It gives you the coordinate of the pixel and the amount of light in it. So it is 3-dimensional image. So it is possible to find celestial coordinates of the comet in FITS images. Then you find the angular distance between these 2 positions, because sky, of course, is a celestial sphere, a spherical coordinate system. Then you find the time when the images are taken. And this way, using this formula, this actually approximation of the small angle approximation, you can find the physical distance in kilometers. Using the physical distance, you find the speed because you know the time. So here I explain shortly what is the FITS. This format preserves information of the images in so-called header, date, exact time of observation, exposure times, and so on. So here is example of the FITS image, FITS header of one of the image. So here object is ISON comet, exposure time 200 seconds, time of observation TM start, UT, universal time start time, and TM end. So 200 seconds from this was observed. So at least you know the first this image when it was taken. Then how to find the celestial coordinates in the images. Okay, this is a rough explanation, quick explanation of what are celestial coordinates. We call them right ascension and declination. These are essentially to sky what longitude and latitude are to the surface of the Earth. So here is 0 hours. We measured in array right ascension in hours and declination in degrees. So not telestial pole will have declination, obviously, plus 90, equator, 0. So to find the celestial coordinates of the comet in the images, these images have to be already astrometrically calibrated. When we get images from the telescope, they are not calibrated. They are just X and Y's. So what means astrometrically calibrated? Every XY on the image plane is associated with the array and deck. Here on the left is calibrated image. As you can click, as you can see this on the comet, you can see that there is a physical image coordinates, X and Y, and there are right ascension and declination. While on the right, it is the same image, but not calibrated. You can see that here you have only physical coordinates. So it means that we need to calibrate the images that we get from the telescope to associate each XY with the array and deck. How we do that? Well, there is something which is called Aladdin. I'm sure that some of you may already know what is it. It's an interactive sky atlas, can be downloaded for free from the Aladdin website, installed on Windows, Macs, Linux, any software, and any processing system. And here in Aladdin, you can do this. This is the image of the Aladdin. So how do we find angular distance between two positions? Well, array and deck coordinates are just like vectors. So finding difference between them, like finding the distance between two vectors. First, array and deck that you get at that comet from Aladdin, we have to convert to decimal values. This is a formula here, using the fact that 1 hour in array represents 15 degrees on the celestial square. An easy alternative, of course, using Aladdin, you can do this. Just click on J 2000D means degrees instead of J 2000 when taking down the coordinates. Then Aladdin will convert it for you. But you can, if you like calculations, you can double check your own calculations using that. Then the angular distance in degrees between the two positions is determined by this usual formula of spherical coordinates, where alpha delta 1 and alpha delta 2 are array deck values first and last position. And then angle in degrees converted to arcsecond by multiplying it by 3600. Of course, there are online cheats in that sense. I mean, you can do these calculations yourself. Then to check it, you can use the software on our IAA website, which is called, you go to CADS, iap.resin, and go click on software. There will be online tools. And in the online tools, there will be angular separation calculator. So here you put in source 1 array and deck, in source 2 array deck 2, and angular separation in degrees will be given you. This is also you can use as a check for your calculations. Then now we found the angular distance. Now we have to find the time when the images were taken. Well, in the image header, there are a keyword called UT, universal time. And this way you can, it's usually given in this, hours, minutes, seconds. So find the time spent between subsequent images in seconds. So here is UT time, 13:47:40. Then you take the second one, which will be maybe 15 or something like this, and you will find the distance in seconds, time distance. Now, finding the physical distance in kilometers from the angular distance. Using this small angle approximation and this formula, we can calculate. So physical distance between first position and second position. And now the trick comes here. Yeah. So what is the d small? What is this distance? So this distance for a particular date of observations can be found from NASA JPL Online Ephemeris webpage. I'll try to click and go there. Okay. To show. Because distance to the comet is calculated by different telescopes from the sky, from the Earth, using parallax method, some other methods. Here, this is horizon system. Here you click, you put your target body, time specification, and click on generate ephemerides. And here is the output with all the explanations, what is delta and delta dot, apparent range of the target center relative to the observer. So here is the distance. So for this particular date, roughly you can take 4.238 something, roughly. astronomical units. This is it. How you do that? Okay. So now we have everything you need to find the speed. Speed is physical distance per time. Now there is a trick, because this is a speed of the comet projected on the sky as we observe it, see it, what is called a transverse component of the comet's velocity. The velocity component parallel to the plane of the sky. There is, which of course will determine, there is a radial velocity, will break down on radialist and actual space velocity. So in principle, we can even find the real space velocity, not just the transverse velocity. So to find the space velocity, we need to know the radial component. Radial velocity is velocity along the line of sight from or towards the observer. And it is again determined by, it will be given by GPL Horizons website, and it is determined from the Doppler effect in the spectra. I hope that you can ask your teachers what does it mean, Doppler effect. Unfortunately, I have no time. Otherwise, I would be happy to explain. So in other words, the same GPL Horizons website provides what is called line of sight velocity, what we said delta dot. Minus means it going towards you. So this is it. So using this, using usual Pythagoras theorem, you can find the true space velocity of the comet. How to do this? Remember, I told about calibrated images, astrometrically calibrated. Well, how to calibrate? You can actually calibrate the images yourself. There are several ways to do it. Doing it yourself is absolute fun. It's like you're there. You can use the same Aladdin. In this Aladdin, you load your image, your FITS file, which is uncalibrated. But roughly we know where the comet was at that time. You can find it in the same FITS header, approximately. So then you load, click, for example, on DSS, on any image given this particular, in the command line, given this particular array and deck. And then click on astrometric calibration. Here you can choose a calibration method, which the great fun is like by matching stars. It's actually, I love to do that. So then you go to your FITS file, click on XY position, match the stars, go to actual image, Hubble image or some other image, click on the same star. It will show here array deck. Then you go again back to your image, click on again star, then go back again to Hubble image and click again on the calibrated star. So then do this something like 10-15 times and click on create. This way it will calibrate your image. And of course, there are other tricks now these days, like cheat ways. There is something called astrometry.net project, astrometric calibration using the web. So here you don't even need to make an account there. You can just log in, click upload tab and menu, and upload the file you wish to calibrate. Once the job is completed, usually after 2 minutes of processing time, you may proceed to results page. And on the results page, you'll get all the calibration data and your calibrated image. Here is astrometry.net. You don't even need to sign in. You just upload, choose file, click on the upload. This will be your image. After some time, it will say success. Maybe roughly 2 minutes. It depends on the amount of stars in the field. Success, go to the results page, click on that results page, and here will be your result. And here is the image called new image.fits. This is your calibrated, astrometrically calibrated image. So you download it, and this way you have astrometry on your image. So this, I have written a book about this, how to do this with some small fun, mathematical fun with comets, some small problems and with solutions. And all this is uploaded to the GitHub with the book, all the data. And January, I have calibrated data. February, I have both calibrated and uncalibrated. And May, September, October, all this you can do it yourself. So what I wanted also to say that my co-author with me on this book is a student. I mean, at that time he was a student, a boy, 11th grade. He was 11th grade student. He was so fascinated by comets, by everything. He even wrote paper on how to calculate the orbit and the perihelion time of the comet. And that paper is here itself on the same GitHub page. You can actually look at it. So please have fun. And I would also suggest that you can do this, calculate the speed, actual space velocity of the comet, check, compare it with, was its ison, was it interstellar, or it was belonging to the our solar system. You can actually do a school project. You can do school presentation, showing the images, showing beautiful images, showing all this and saying, this I calculated this, the speed, actual physical velocity of the comet, and as it was coming to the sun, it was accelerating. Of course it will. And you can explain why. Okay, I would like to stop.
Thanks a lot, Margarita ma'am. And
now I will wait a second. I will try to stop the sharing. Yes.
So thanks a lot, Margarita ma'am, for this insightful visit to the what can be said, the distant visitors that keep on visiting once in a while to this are we the earthlings. So I hope that especially for the teachers, this keynote address that was given by the honorable speaker, Dr. Margarita Safonova, she is here right now. If you have any doubt with regards to this sort of a thing, you can really ask, because in my opinion, personally speaking, this particular thing, as Margarita ma'am has just said, it could be really a wonderful school project. In fact, for the entry-level college students also, this can be really, really wonderful project.
I will say thank you very much, Margarita. I really enjoy having you present about comets.
Thank you.
And I can't get my computer to spell it right. So it keeps coming back with comments instead of comets. But I appreciate what you have done and what you are doing. And perhaps we should get you to write a short program in iSTEAM about a friendly comet or meteor or both. Maybe the difference between a comet, and a meteor.
Yes. I'll be happy to talk about it.
Hello. Am I audible to you all?
Yes.
So I'm really sorry that because of that, because it actually started, a thunderstorm started here, and so a little bit of disturbance happened. So I hope that I have not, because I kept on talking to myself, I was not looking at the screen. So I just would like to continue that this can be really a wonderful project, especially speaking when we are talking in the terms of the students who have just seen the basics of the mathematical physics, who are just seeing the intertwining features of the mathematics and physics come together on a same page on a single platform. So all the teachers who are here, all the educators who are here, and all the students who want to make a mark in the field of science, this could be a stepping stone. See, you go through the GitHub repository that has been shared by Dr. Margarita. You can look into the links that really Dr. Margarita has talked about. You can keep on touch with us, and you can keep on interacting with these professional scientists of the order of Dr. Margarita and her colleagues. You once in a while, you plan a visit to Indian Institute of Astrophysics. I definitely assure you that you shall come out as another being once you visit the campus. Such is the aura of that particular campus and the hard work and the dedication. And it not simply is, you can say, a professional body, but it is extending its hands to the students also in the form of a very specialized outreach wing. If your institution contacts the outreach activity in charge, I think Dr. Niruj Mohan is the outreach in charge. He can arrange for the probable activities, even though there may be less activities as far as the outreach are concerned. but there can be a bonding. You can really bond yourself with the institutions in the days to come. And with these words,
sorry, Amritanshu, I just want to add about
Yes, ma'am.
Neeraj that actually now what they initiated is something called Shadow the Scientist program. So the students actually can come and as they assign themselves or choose the scientist, and they actually follow that scientist from day to day for a week or 2 weeks. So to actually, that is what is called Shadow the Scientist. So that they learn how we work, what do we do from day to day. So they actually there is a program in our institute about that.
So great to learn from you. Now you can see, this is what the interactions can lead to. As this is the latest thing that we come to know, the latest development, courtesy to Dr. Margarita, that IIA is all open for you as the student. Now it's you to take a step forward and visit institution par excellence. So you just keep in touch with these premier institutions, and definitely your academic career, your citizen scientist career, your amateur career, your professional career, hopefully in the days to come, will reach the heights unimagined. And who knows that Chandrayaan 4 or the upcoming missions of India, you can also be a part of, as part of the teams under the guidance of the professional scientists like Margarita ma'am and all the others involved. So with these words, I really express the thanks of the entire iSTEAM family to Professor Dr. Margarita Safonova for giving us such a wonderful insight and into not only, you can say it was a keynote address, but it touched really the core of the heart of all the educators and all the students simultaneously, which is very difficult thing to do. And people say that professional scientists, they are not good at communicating, but you have broken that boundary as well today. Yeah, I think you were able to address both the level of the students. There is something in the field of chemistry which is known as band gap between the conduction and the valence band. So you have bridged that gap today. So all the students and all the teachers, they are on the same page after seeing your insightful address. So once again, wholehearted thanks to you on behalf of iSTEAM family, Dr. Margarita ma'am. So moving forward, now this is the final thing that we are really waiting for, because we have been interacting with the students as well as with their teachers for last, you can say, 4 days. Now, almost all the days really are over now. So now it's the time for the feedback from the teachers. And as I can see, there are a couple of teachers who really had agreed with us to share their feedback. One amongst them, a couple of them, as I can see right now, is Shri Ashwin Shenoyji and Shri BLV and Ananda Babu sir. So in the order, I just would like to invite Shri Ashwin Shenoyji to take the center stage and share your feedback. And you will be followed by Shri BLV and Ananda Babu. Ashwin Shenoy sir. Please unmute yourself. Please start your video and share your feelings with us, your experiences of last 4 days.
Hi, Amritanshu sir. I'm unable to share my video right now. Okay, I just got permission. Can you see me? Can you hear me?
Yes.
So I really enjoyed this workshop, just as I've enjoyed all the other conferences and activities conducted by the GHOU. Some years ago, I think you may know that I have a background in astrophysics. And some years ago, I was interested in starting astronomy activities here in Mangalore for both the general public as well as for students. The thing is, I did not know how to go about it. One moment, sorry. Just got a WhatsApp call. Timing. So I did not know how to go about it. And I have to say that the very first GHOU conference that I attended, that was exactly what I needed. Right? Your presentations had a wealth of experience, and you introduced us to so many resources, right? Free resources that could be accessed by the general public, by students, by institutions. And that really inspired me to move forward. So I have to thank you for really helping me take this forward in Mangalore. I think for me, the highlight of this talk was the introduction to the NASA Micro Observatory Network. I had no idea that we could just access images from such an advanced robotic telescope. And I think this is what will excite my students the most when I introduce it to them. So apart from that, I'm looking forward to participating in all the activities. You've shared so many of them. I took almost 2 minutes to open all the links because I thought the links would disappear when this meeting ends. So I'm hoping that I'll be able to bring a good group of students to participate in all your activities down the road. So thank you.
Thank you. We look forward to seeing much more of you as
you.
the year goes on.
Thank you, Ashwin sir, and hope that the association goes stronger and stronger, as said by Vani ma'am. Now there are two more teachers who are in line. So there is Ananda Babu sir, followed by Prabhat sir. So Ananda Babu sir, over to you, and Prabhat sir, we are coming with the next. Ananda Babu sir, please unmute yourself so that we can hear the feedback from you.
Sir, a very good evening to one and all, sir. I am really glad to all the higher hierarchy, sir. Right from Amritsan Suj, sir, Amritsan Suji, Bonitarba ma'am, and Margarita ma'am. Because I am a part and parcel of Moonovers in 2021, ma'am. And regarding with IAC Indian International Asset Search Campaign, I am part and parcel of 2020 से मैं ये सब में participate कर रहा हूँ. Whatever it may be, this all these 4 days with that due to different sorts of administrative and different activities which has been certainly belonging to the school, pertaining to the school. I was busy from last 6 months, but now it is a great turning point. It's a great turmoil. It's a great turmoil also. By participating in this 4 days workshop, online workshop, it's a great fortune. And moreover, I very much thankful to Bonitaba ma'am and Margarita ma'am and Amrita and Suji for giving this a great opportunity. And there is a plea, sir, Amrita and Suji, regarding with the mobile photography. We should have another session, sir, regarding under your supervision. This is my request, sir, regarding with our students, on behalf of our students. Thank you.
So thanks a lot, Ananda Babu sir, for your candid remarks, and we definitely accept your suggestion, and we shall be planning it because this is just a beginning. And from 6th of October, it is an International Space Week that is beginning. So we may plan a specialized session if the academic curriculum or academic schedule of the students permit. Then we shall keep in touch with each other, and it will be an open session for all, not simply for your students, those of you who are interested, but it will be student centric. So I would request you can say more and more students in such sessions. Now, finally, if I can see Prabhat sir is here. So Prabhat sir, you are the final teacher who is going to share his feedback with us. So Prabhat sir, over to you. If you can unmute yourself and show us your video, we will be really glad to hear your feedback.
Okay. Hello, I am visible to all?
Yes, sir. Yes, sir.
Oh, okay. Thanks, Amritansu sir, for such a nice workshop, which you have made me a participant in this. And especially, I want to thank Mrs. Chitra Singh ma'am, who introduced into the WhatsApp group, which is maintained by Amritansu sir. So first of all, I would like to say that nowadays some half-yearly examinations are going on in my school. So today I have gathered mostly the students of 8 to 12, and I asked them and I have shown them about the workshop, the Padlet, and they were very eager to know and they were interested. And today only I have told them, those who are interested, then please kindly send their names. Now, till now I have received about 12 to 13 names by the students. That's why I am interested about this, and they are really interested about the Moonovers program, and so many programs that Amritansu sir has shown. So has given us opportunity to take participate, and we are very much eager. And the last line, which is very important by the Robert Frost that we have heard in the poem, and miles to go before I sleep, and miles to go before I sleep, means the astronomy and the cosmology, and the miles to go before I sleep. And thank you, Amritansu sir, for such a nice opportunity. And it will be my pleasure to attend if you are able to organize one or more workshop on the mobile astrophotography.
So thanks a lot. Thank you, Prabhat sir. And now we are just into the culminating phase of this Lunar Nights. Every good thing has some ending at some certain point of time. So we have almost reached that moment, and we have overshot our time, say about by 15 minutes or so. Don't worry. So at this juncture, I would request all of you to switch your cameras on before we move for a formal vote of thanks, because as is being said by the wise men, photography is the best memory. So we want you all to capture, we want this particular thing to be captured. If you all are in the state, so that we really can switch your cameras on, we really shall be happy. I am requesting the other two also. So if possible, please start the videos. And Rishwardhan's ji, if you can come onto the frame, because you cannot see. Yeah, Rabia ma'am, if you are able to share the screen, so share your video, we will be happy. So with these words, I request you to all to have a little bit of smiling face, please. So that we can have this particular photography session. Thank you. Thanks a lot. So yeah, okay, Rabi ji, I have taken a photograph as well. Thank you. Thanks a lot. So now the all important, so if anybody is remaining, I would request you to kindly switch your cameras on, so that I think a couple of people, they have joined more. If you want, we can add you also to the frame. Please keep your camera on, so that we can take this final snap, and we will definitely be posting this to Office for Astronomy Outreach, the way in which we join together. आप सभी से निवेदन है कि अपने अपने कैमरास खोल सकते हैं, अगर हमारी ये इच्छा है कि ये फोटोग्राफ का जो फाइनल स्नैप है वो ऑफिस फॉर एस्ट्रोनॉमी आउटरीच में जरूर जाए. So yes, Rudra ji, please. Yes, sure. Thank you. So you know what happened is, this was a traversal that we did in the last 4 days, and in fact I can proudly say that it simply was not a program, but you can say it was a mini online conference that we did. And if we expand the sessions, the quantum of the sessions, say what Dr. Margarita ma'am said today, if we make it say 1 hour, it becomes definitely a conference session. So it was, you can say, in the name of a small program that we tried to produce in front of you the maximum that we can give to you in the name of the guidelines that were presented to us by Office for Astronomy Outreach of International Astronomical Union. So I hope that we have tried our level best. Now, all the teachers who are here, I would humbly request you that if possible, whatever work that has been done by the student of yours, try to reflect it in the Padlet. And what can be really done is, there is a competition that is being organized by International Astronomical Union's Office for Astronomy Outreach. The deadline of that particular program to upload the entries is 10th of October. So my humble request to all of you is, if your students have done something exceptional, even if you have done something exceptional, whether it is in the terms of photography, whether it is in terms of imaging, whether it is in terms of poetry, whether it is in terms of story writing, whether it is in terms of drawing and sketching, whether it is in terms of micro observatory work, whether it is in terms of the telescopic work, whether it is a freelance work, whatever sort of thing is, if it is related to astrophotography, astronomy, your cultural astronomy, your moon sort of thing, that anything that you have done, please share with us on the emails that I am just going to put it here. I am going to put both the emails into the chat box. If you can share with us, we will be happy to send those as the entries for the students to the Office for Astronomy Outreach. So this is the first email address that I have shared. And then this is the second email address that I am just going to put it here. So these are the two email addresses you may please take a note of. And while sharing these things, just write a little bit of details about what you have done, what was the thought process that was being carried out in your minds while these certain things. For example, if you're writing a poetry, what was running in your mind while you were writing the poetry? If you were sketching something, what was the thought process in the back of the mind? How you were trying to connect your culture with the thing? We will post verbatim, that is as it is, whatever you have posted. Yes, definitely, if it is in any other language other than English, then we will do the translation part of the work and will put that work forth in front of Office for Astronomy Outreach. That is our responsibility, with due credits to your original work as well. So this is a final request to you. With these words, I thank all the entire fraternity of the educators, the fraternity of the professionals and the amateurs who have been involved with us, and the team, iSTEAM, comprising of Ms. Bonnie Truber ma'am, Mr. S.N. Sukumar Iyer sir, Mrs. Chitra Singh, or Mr. Suresh Meduru, Dr. Suresh Iyer, and all the people who have really been involved, working 24/7. You can see in the very fag end of the day, sometimes at 1 a.m. in the morning, you might have seen the video being uploaded. Sometimes in the afternoon, you might have seen the video being uploaded. So there was a teamwork that was going all the way around. I simply am the mouthpiece of this entire team. Keep connected with us. Over to Bonnie ma'am for a formal vote of thanks before we come to the formal closure of the session. Bonnie ma'am, now the reins belong to you.
Thank you very much. And really, I have only a few words. I appreciate you all being here. I need to know who the person was who posted the quiz yesterday about having a conference in 2004 in January, because I didn't catch the name or the name of the school. And I definitely want to look on that. Is that person here? Would you please raise your hand? Nope. Okay. At any rate, I thank you very much. I thank you for being here. I really appreciate the work you've done and the work your students have done. And I wish they would continue. They have a Padlet. They can take pictures of the moon with cameras. They can draw the moon. They can write stories. And that Padlet can take probably over 100 more images. So please let them go on and be creative, and also join us for the Moon Over Us project. Thank you very much. I look forward to seeing you all in that project. Bye for now.
So thanks all. So let's have the countdown from beginning with 10, 9,
Thank you so much.
8, 7, 6, 5, 4, 3, 2, 1, and the meeting ends. Thank you.
Thank
See you
you.
soon.
Thank you.